Hola people, so today we're going to talk about vectors, and I know that it's usually for physics, so like a vector would be velocity, whereas the scalar quantity would be speed, but we don't care about that because this is math. So, this is the general form that you're going to see of a vector, so it's like the whole thing equals the horizontal component plus the vertical component, so when you graph it, it's going to be like, you know, the I here on the x-axis and then the j here on the y-axis. So we're just going to discuss some properties of vectors. So first and foremost, you want the magnitude, which you denote as like line v line equals the square root of a squared plus b squared. So if you have a vector equals, say, 3i plus 4j, so that's 3 down here, that's 4 up here, so 3, 4, excuse my drawing, but this is explain everything and it sucks. It's a triangle, so you can see here that the entire vector would be 5, and then here, the magnitude, line v, line, it would equal 9 plus the square root of 9 plus 16, which is 5. So now I'm just going to talk a little bit about a vector addition and vector subtraction. So these are your two vectors. So we have vector v, and vector w. And so if you want to add those vectors, you just do v plus w equals a1 plus a2 plus b1 plus b2 j. And then if you wanted to subtract them, so vector v, that should be plus, minus vector w, it would be a1 minus a2 times I plus b1 minus b2 times j. So just say that that vector v is 5i plus 4j, and that vector w is 6i minus 9j. These examples are also in the text. So let's try and find v plus w. So if you take the rules accordingly up here, then that would you would take these coefficients here, so 5 and 6, you'd add them, so 5 plus 6i plus 4 plus negative 9, so minus 9j. So that would end up equaling 11i minus 5j. So that's your angle. That's your vector v plus vector w. And for vector v minus vector w, same thing, pretty simple. So it would end up being 5 minus 6i plus 4 minus negative 9. So you're going to add those j. So that would be negative I plus 13j. So just add the coefficients of the add or subtract the coefficients of I and j as needed. And so here, if you want to multiply vectors by something, then say that k is your coefficient. So if you want to say like I don't know, like negative 3v, or 3 times the vector v, and vector v is, say, 5i plus 4j again, you would just multiply the coefficients by negative 3. So that would end up being, 5 times negative 3 times I plus 4 times negative 3 times j, which would equal negative 15i minus 12j. So yeah, it's pretty straightforward. So lastly, we're going to talk about something called the dot product, and that has to do with like ways of representing how work is done in physics. But I'm not going to explain that because this is not physics. So it's basically just you write it like the dot product of v and w. I believe it's also called v dotted with w, but I am not sure. Equals 1 a2 plus b1 b2 if vector v is a1i plus b1j, and if vector w is a2i plus b2j. So let's block this off. So say that we wanted to find, the dot product of v and w. Let's make vector v be 5i minus 2j, and vector w can be negative 3i plus 4j. So all you're going to do is take the coefficients. So let's look at this part first, and then this part first, or whatever. So this would just turn into, negative 15 minus 8, which is negative 23. And that's basically just what it is. And for another example, if you wanted to do, v, like the dot product of v with v, then you would just do, square those. So it would be 5 times 5, which is 25, plus negative 2 times negative 2, which is 4, so plus 4, that would equal 29. So it's pretty simple. Now, an alternate way of finding the dot product is to multiply the magnitude of both vectors. So line v, line, and then line w, line, times the cosine of the angle between them. But it's actually more helpful because we're usually trying to find the angle. So then you can just do some dividing, and you can get the cosine of theta equals the dot product over the magnitudes. So say that we wanted to find the angle between vector v and vector w. So we need the dot product first, and then we need to multiply the magnitudes. So the magnitude here, so I'll just do mag v, then mag w. That would be the square root of 13, because now square root of 9 plus 4, and then that would be the square root of 17, because it'd be negative 1 squared plus 4 squared, which is 17, square root of that. And then, of course, the dot product, so v dotted with w. So you would just multiply the coefficients. So 3 times negative 1 plus negative 2 times 4 is negative 11. So your final setup would be the cosine of theta equals negative 11 over the square root of 13 times the square root of 17. So if you multiply that out and then take the inverse of both sides, then the theta ends up being about 137.7 degrees. And that will work for any problem where you have two vectors. And while we are talking about angles, if you ever hear the word orthogonal, that just means that the angle between the vectors is 90 degrees. So by extension, if the vectors are orthogonal, excuse me, I can't say it, then the dot product will be 0. And so if we're being tested on the dot product, I'm not sure if it's important to know the application, but just in case. So the work done by a force to move an object from A to B would be the force with the dot product of the force and the distance. But it's easier to use the other version, so it would just be work equals force, or rather the magnitude of the force times the magnitude of the distance moved times the cosine of the angle. So in the Blitzer book, it says that a child pulls a sled along level ground by exerting a force of 30 pounds, although, in regular physics you use newtons, on a rope that makes an angle of 35 degrees with the horizontal. So how much work is done by pulling the sled 200 feet? So that's just simply, work equals, the force would be 30 pounds here, but, you know, don't do that on a physics test because you'll die. Times the magnitude of the distance, which is 200, and then times the cosine of 35, which turns out to be about 4,915. And then the unit here is foot-pounds, which is stupid, so don't do that. Just, you know, listen to your physics teacher. Ew, that's weird. And that's all you need to know about vectors. So yeah, have fun and don't use foot-pounds in physics.